Okay, so in this lecture, what we're going to look at is how do we do the particle engine, right? So I will do a sample particle engine. There are so many other ways that you can do it. Um, so what I'm going to propose here is just a simple engine that you can generate particles. Maybe I'll draw dots in a certain pattern. So that's what I'm going to do, right? And I'm going to use the same code that I have used for the vertex shaders. Reason I'm using that, well, it's already shaders are inbuilt in there, so in that case that will be useful, right? A few things I will change here. I don't want the shader for my teapot, just leave it without it. So I'll just get rid of that the function, right? So yeah, let's before we start, let's run this. So I don't need location check either. Location check you don't need. Translate, yeah, maybe I move it to the corner. Yeah, so yeah, I just get rid of a few things there. So I should have something look like initially what I had was the triangle and the teapot, right? So this is what I have. So I'll leave it like this, and I have some the particles, right? Why I'm using the same? Well, if you want to apply particles to your, I mean the shader coding for your particles, you can use this code. So that's the reason I'm going to use this. Okay, so let's start. I think it's better. I'm creating a class here for the particles. So in that case, it's much more convenient, and it's object-oriented programming. If you call C++, and it helps you to make some instance of particles. So let's have a class. It will be much easier. So let's do. Otherwise, your code will be get longer and longer. Alright, so let's create a class called particles. So then we'll talk about particles a little, right? So I'm going to call this underscore particles like that. And so let's go ahead and create that. And I'm asking whether you want to plug this to your project, yes, and then it's a debug, and then also the release. Alright, so then double click on this and move this bigger. So this is the structure I have. I have to add a few things in there and make it look nice, right? I mean convenient, right? So let's see what other things I should add here. Well, this is based on the lecture. So we have done one particle lecture talking about very basic things of the particles, which is listed here, right? So this is what we had we talk about as a particle. This is the way that it should work. You will have a random generator. To the emitter is the initialization, and then update everything and then render it, and again on update. So it will go on and on like this. So this one will produce some particles, and it will jump here and update each status each iteration, and then it will print it, right? So this is the path. This is the thing that I'm planning on doing, right? And another thing on the particles, we were talking about the structure of it like this. So we have a type def structure. It has a position, direction, forces if you want to apply more, and all that, and you call it particles. So let's stick with this and then create one, right? So it will be more parallel to this process, right? So that's what we're going to do now, right? Okay, so let's get back and create some variables here that we're going to use. Yeah, so as I said, it will parallel to the lecture that we did. So in that case, inside the class, I'm going to have a type def structure, right? Yeah, you can use without it, do this without it, but I will do this way because that's the way I teach you, right? So type definition struct, and let's have some values in there. Maybe some you will need it, some maybe you can extend later. So of course I have to have a live or active particles, and then particles has positions, so float x position, and let's have float y position, obviously. Yes, so let's have a caps lock P, and so that is x position, y position. If you want 3D, you can put z position as well. Well, I will have 2D one, right? Just for you to understand better. Maybe x direction. What direction of x you can move, and the direction of y of your particle. So are this one caps, right? Those are directions. Maybe if you want to use mass, you can. So anyway, I'm just going to throw that, and radius, size of it, right? So the radius. Maybe I will use radius for something else in this particular thing. And then I'm going to have explosion kind of one. Okay, so this will have a radius that's going to expand. So that's what I'm going to do. So in that case, I will have explosion. Maybe some of these I will use, some of not. But let's just in case, because I'm writing this on the fly. Let's have some variables and think about it later, right? Whether I'm going to use it or not. So the explosion radius. So yeah, I'm going to make it explode. Some angles, right? Some angles. If you want to do cosine, sine, you can do that. And colors, right? You can set different color. So in that case, I can go with the scale of 256. I mean, if you 0 to 255 or something else. Let's have 0 to 255. So color as an integer, right? So that's what I'm going to do. Color. Right. And yeah, so I can. You can have RGB if you want, or one just a one color in there. I'll think about that later. And then velocity, right? So I can make the speeds velocity x, float velocity y, right? Velocity y. So if I'm going to use that, and then if you really want blur effects, so you can have alpha. Right. So as I said, I will use some of them, maybe not only few of them, maybe, right? Maybe some will not relate to what I'm going to do, right? But anyway, you can always extend. So I call this particle. Right, so that is that, and then I need few things that I want to define here. I think max drops I will define as max drops, maximum number of drops that I want to put in there, and maybe I will define the gravity as well. So in that case, if I'm going to use those things, Yeah, since this is a class, maybe I will have the glut header here. If I need that, I will put it there. Yes, I'm going to draw this thing. So let me go to the header and go ahead and apply maybe all this up to here. That's just in case, right? So I'm going to copy this. Maybe only glut part will do. Yeah, just have this, that's fine. So let's have that here. Right. Okay, so all that will help. I want to define a few things here. So I'm going to define the gravity if I'm going to use that. Gravity. And let's set it up for some value. I don't want to put 9.81 because that is too high of a value. Maybe 0.01 because my screen is very small, right? So in that case this will help. Max dots that I have, let's have max drops. I call it drops. Maybe 50,000. Yeah, 50,000. So I'm going to create something with 50,000 dots, right? Okay. Do I need pi? Maybe I need pi if I'm using some angles. So I will define pi. So that is 3.14159. Right. Okay. So some of them I will use, some of don't. In that case you can alter, come back and alter. So I've just in case I just create this structure. Right, and then I need some the drops. Of course, this is the class for drops. Particles. So let me call it particles. Right, so that is my particle. Right, particle is my structure, and let me call it drops. And then I'm setting this up for the max drops. So max underscore drops, that's what I call it, right? Yeah, this is what I call it, right? So that is that. I'm going to use that, and then draw particles, update particles, and generate particles. So that's what I'm going to use. So void draw particles is the render part. So let me have render particles. Right. So that is rendering part. I need the emitter to generate, right? So generation is the emitter part. So let me have emitter here. Emitter, and then let's have some direction. So of movements, right? So the X position and Y position, and then I will have update, right? So let's call it update particles. So let's call it particles, right? So, and then I don't need anything there, right? Alright, so this is for render, and this is for update, or no, not update, generate, right? So this is, I would call it emitter. Emitter is emitter as itself. Emitter, actually you need two TER, I guess. So let's call it like that. Alright, and then obviously updating the data, right? So this is for the update. All right, so these all, I think this is enough, to create the particle on this, right? Okay, so let's go and move on to the next step, which is I'm going to save this and have some values in it. So let's save this and then go to my particles.cpp, and I'm going to close those, call those classes here, I mean the methods here. So you insert all the methods without implementation. Obviously you have 3 of them, so I'm going to write some code in there, right? So that's what I'm going to do. Initialization, if you want something to initialize from your values, yeah, you can do this. There are a bunch of values I have here actually, so I can initialize each of it if you really want, right? And of course I'm creating that for loop here, so if you want to initialize everything, you have to go through a for loop and do that. So it's a lot of work actually, because it's 50,000 dots that I'm taking care of here, right? Okay, so right, so let's generate a render, emitter, and update. So that's what I'm going to do. Drawing the particles is the easiest one, so let me take care of that first. This is the render. Obviously I will have push and pop metrics, so we'll have GL push matrix, right? And then if you have GL push, you'll have GL pop, right? Pop matrix. There you go. So GL push and pop, and then in the middle of it, I'm going to draw points, right? So I'm going to draw points. So this is a GL begin, and I'm going to draw GL underscore points. Points, yes. Oops, yes. So GL begin, and then I have to have GL end, obviously. GL end there. So now, let's have something like, yeah, the point size. I like to have a little bit bigger points than just dots. So let's have just the same way that we used to do the point size. So how do you do that? Is GL point and size, right? And then let's have 3 there. Okay, right. So that is the basic, and then what you're going to do here, I will have a while loop instead of for loop. Oh, I can have for loop instead of, yeah. Okay, so let me think whether I should have while loop or the for loop. So we know one thing, which is the number of drops that I'm going to use here, and all right. So let's have a for loop. Yeah, why not? For I equals 0, right? I less than, I'm going to print only the number of, I will have defined something as number of drops, because I don't want to print all 50,000 at once, right? So it will be handling by the number of drops I'm going to use. So let me go back here, define something as number of drops. So that will be helpful when I'm going to use this, and whenever you want to control your points, right? So let's create something called number of drops, and using that as my handler, right? So yeah, so let's have a number of drops as my the handler of the emitter. So it is int num drops. So I'm going to have that. Okay. So right. So let's go back here and make sure you save. So this is going to be num drops. Num drops. That. And then number of drops, and then I plus plus, right? Yeah, so this is my loop, and then I'm going to have whatever I have, I'm going to draw into the screen. So that's what I'm going to do here. Whatever the number that I have, I'm going to draw this, right? Only if it is alive, right? So I have to set if the drops is the structure that I created, and I of that, right, dot alive, right, alive, and then if it is alive, then I'm going to draw this. So it's easy to draw because it's just a dot, so I need only GL vertex one time, right? And I will have 3F, of course. It's my 3F on this. Yeah, there you go. So what are the 3F's positions? Drops I dot X position, right? Xpos, right? And then I have drops I dot Y position, Y pass, and then I will push this back to minus 1.0, so you can add a little back behind it, right? So yep. So that's all I need for my for loop. So it will be running on a for loop, and then just do this part, right? Okay. And so I think that will do for my display, right? So this is, it will draw everything here. And the lifetime, I mean the emitter part, and the updates. So I had to do generate particles, right? So when you generate particles, I'm setting up some path for that to move, right? So that's what I'm going to do. And so I'm setting the path, and then update part also in there. And for the emitter, what I'm going to do is I'm going to create some the things here. So how can I separate the things for the emitter and the update? So update is changing your movements all the time, and the emitter will generate and set up its primary movements. Okay, so there are two things I can do here, and each one of them will be mixed. Actually, these two are going to be mixed, because generate particles, I will set up everything that I want to set up as with the initial values, but and also I want to make it the paths and everything in there as well. Okay, so let me think. Anyway, all these three functions has to be updated each time, right? So emitter will generate stuff, update will update, and then the render will render. So all this in running on a loop. Actually, there's nothing will go to the initialization in this case. Why? Because I'm generating a few number of particles. Once it's die, you will regenerate that, so it will come back to this and have to process these two. So because of that, these two are actually combined. So where are you putting that? Well, the emitter will generate some number, and then of course updater will update it. So let's have the emitter part first. So the emitter part, I'm going to create So number of drops, so let's call it integer value of new drops, how many drops I need, right? And it's going to be random, so you can use either srand or the rand, and each time I want to generate 60 of them, let's say 60 of them, right? And +1 because no zeros, right? Okay. And yeah, you can have drand 48 or srand, or there are so many other ways that you can do it. I'm just using a simple, very straightforward one, which is not really a random function, but it give you some numbers, right? And what happens if it is exceed your total number, right? So now I know num drops, which is the number of drops I have, right? And plus new drops, which is I just get 60 at a time, right? Out of 60 at a time. So that's the new drops. If these two are bigger than my maximum number, right? So the max underscore drops, what happens, right? So what should I do in this case? Well, in that case, the new drops should be equal to the difference of these two, right? So it is the new drops should be equal to max underscore drops minus, right, num drops. So what is this means is, well, you take the last part of it. If it is really if it is, you should not get over a drop, so it is just the last bit of it, so I'm going to use as that. So this will take care of overflowing your any of the arrays, right? Okay, so now so I have that, and then until I have all the available drops for int I and int I equals 0, I less than num drops, number of drops, right? Num drops plus new drops. So this is the amount of total drops in when you're rendering, right? And so I plus you set this guy the drops I to be true, right, to alive, right? So alive equal true, so they will be live, and set the other things like drops of I dot x position, right? So xpos, let's set that one to my mouse click, maybe yes. So in this case, emitter, I'm going to take some values. I will set it up to mouse click at the beginning. So mx and my. So I want to follow the mouse on these things. Yeah, so that's a good idea. So let's have it like this. And then drops of I dot y position, right? And then that is be my, right? So those two I will have in there. And what else? Yes, the explosion that I'm going to use. I mean, this is going to be explosion. That's what I have in my mind. So the drops I dot explosion radius. I set this to 0.1 for now. This is the radius of explosion, and I'm going to play around with it a little. And then dot angle. Yes, angle is something I should use here. Angle, and that will be a random value. Random value, and then always within 360 limit. That is your angle. Okay, so what is that? What else I should do here? Well, set the velocities of the drops. Okay, so the velocities of the drops, I'm going to use velocity x. So these are the values that I have to worry about how I should take care of it. Let's have the multiplication of angle and the radius of the explosion. See what happens. So my angle is actually a random value, right? So it will generate with the angle, and that will define the direction I want to move it actually, and also the radius will control how far it will jump. So let me have something like this sine, and then have the drops I dot angle. So that is the angle I'm going to give them, and you multiply that by drops explosion, right? So drops I dot explosion. So it will be make it very small radius, right? Okay, so that is for your x value. Let me have the same for my y value. Okay, so this and then like that. So this is for your y. I will use cosine for the y, so it will make a cycle, right? Cosine, so xy, and the cosine will get the drop angle, so the rest will be the same, right? Yeah. Do you want to take care of the alpha? You can. Well, anyway, so if you playing around with the alphas, you can. So let anyway address that as well. So I will address all the things. So the alpha. Let's have a random value as well. So it is rand again, and well, alpha has to be a point something, right? So anyway, let's get it less than 100, and so it is less than 100 divided by what? 0 to 100. Even you get 99, you should get 0.99. So I will have divided by 100. Right. So that is alpha values. Let's see how it goes. Right. So I'm not sure. Right. So one thing I have to do is number of drops that I have. Num drops always going to be increased by the generated number. So it is a new drops, right? New drops, yeah. So that will add to your number. Why you need that? Well, you're going to anyway, you're going to print everything, right? So the render everything. So render everything in that function. I just call it here in my render thing. I call it number of drops. So in that case, I had to upgrade number of drops here. And if it is hits the number of drops, it is. I mean, if it is hitting max drops, you should set it to 0, right? So in this case, num drops greater than or equal to max drops. Max, I think drops here. Drops, yep. In that case, let's set num drops to equal to 0, right? Otherwise no. Right, so it will take care of that. And so yeah, so this is about generating. So that's my emitter. Let me compile and see if I get anything not good. Might. Okay, so I have one error here, which is this line. Obviously I should not have semicolons, right? It's just a definition. So let's compile again and see what else I have. Oh, it's all good. So that's the only error I had. Okay, now let's go ahead. Now I have emitter generating it and render doing that. So but I had to change some stuff. I'm going to update stuff, right? So what I'm going to update here? Well, let me see what I'm going to update. So okay, so let's update my my drops actually. So that means I'm going to upgrade the velocity of my drops, right? And then I'm going to see set the alpha value to handle the display things, right? So that is a good way of making things disappear at the end. So let me have this here. So I'm going to update again for, right, int I equals 0, I less than num drops, right? Num drops, and then I plus plus. Right, so now I'm going to update things here. The first thing I should do is change my position. So drops I dot x position, right? X position, and so plus equals, this one is drops again, and I dot velocity. So we have something called velocity, right? That's the velocity x. So I'm going to change that. And drops I dot y pos, right, y position equal plus equal drops I dot velocity of y, right? Yeah, so those are two things I want to update here, and I want to do this only if it is alive. So if drops dot I dot live alive, right? Something like alive. Yes, is that what it is? What I have? Yes, alive. So only if it is alive, I'm going to do some things in there. Otherwise, you should not worry about it, right? So yeah, I have that. If it is only alive, I'm going to print this. Okay, so yeah, we need another bracket comma here, and at the end right here. So it's a very simple one. I'm just changing the velocity here, that's all. Maybe I will play around with alpha to disappear things, right? If you really want to do that, and then set the colors if you want, you can, right? So okay, so yeah, let's run this and see. So before that, I had to go to the main.cpp, right? In here, of course, I have to include my particles. So let's go ahead and do that. Include particles, right? Particles, what did I call it? Underscore particles. So underscore p. Okay, there you go. Right. So I have that on the top as the library, and then I had to create some here, the instance of it. So it will be instance of my thing. So let's me open here, call it underscore particles, and then let's call it PRT as particles. Okay, that's fine, just the name. Right. And the pointer for that, and then I'm going to create new underscore particles, right? There you go. So now I have that particle thing there, and so then you just have to do is what? You just have to call it in your display, right? So I'm calling all three in my display. So that's how I'm going to display this. So let's go ahead and go to the display, right, and then set up a color. Actually, I did not set the color. You can set the color in your particle thing as well. But here, let's have something like PRTS now, right? Particles. First thing you do is you emit, right? Emitter. Emitter has two variables. One is your x value, and one, so it is a mouse x, right? Mouse dot x and comma mouse dot y. So those are two values sticking it in, and it's emitting, and then yeah, after that you draw, and then you update, right? So PRTS again, and then you draw things here. So I will say draw particles, right? Oops, how come it did not come up? Emitter, draw. Oh, I call it render, right? Render particles, right? So that's what I call it. Let me check one more time if it is not coming up. I call it render particles, and then the update particles, right? Yeah. So yeah, so this is what I want to do here. Render particles right here, right, and then the last one is particles, PTRTS particles, and the pointer, and then I will say update particles right here, right? Right, so this is all I need though. So it will move with the mouse for sure, and well, one thing I like to have this. Let me run this anyway. See what happens now, and then do the updates accordingly. Oh, because of my P is simple. Let's have simple P here as well, and then go all the way up and change this to simple P instead of capital P, right? Yeah, right here. Right, so now let's run it. One more error, which is capital P to simple P, and compile again. Alright, okay, so I don't see anything yet, so let me see what's going on and then come back and fix that. Okay, so let's look at this. One thing I realized, here, right here. So I don't want to initialize everything each time. I want to do whenever I will generate the new drafts, right? So new drafts is the one that I want to initialize here. So in this case, I would say num drafts, from now drafts, num drafts to the new values. You do this stuff, right? And oops, there's a typo right here, and this has to be equal. So that will take care of only the new ones, obviously. And what else I had to fix here? This looks all right. So let's go ahead and run this, and then see if there are bugs to fix. Since it's running. Right, so now I have my mouse is a little bit off, little, not a little, a lot, but you will have something like this. Now actually it's running pretty nice, right? Only thing is I did not set these to dead particles. Actually it's live and live all the way. So one thing I can do is use this alpha value right here, range from 0 to 9 with the floating point number, right? So when you do this, and when it is reach, let's subtract some values for this. So then that means in updates I would do drops drops I dot alpha value, right? Alpha value, and then subtract equals 0.01. So then it will subtract each time. When it's reached 0, I'm going to set my my life of time was expired, right? So that means if the drops I dot alpha is less than or equal 0, right? That means I'm going to say drops I, right? And drops I dot live false equals false, else nothing, right? So else no, right? So that take care of that. So you'll have a lifetime, and then it will regenerate it, and it's moving on. So I think that will be a good way of doing this. So let me see. Right, so you have that, and if I click this, it's just showing it everywhere. Right. Okay, so I don't want to put that in a -1, so let me have it in 1. So it will have it a little bit front of the screen. That's one thing. And I have push and pop here, so I don't need push and pop in my display. So anyway, I don't have it here. That's fine. And a disabling texture here, that's good. If I want to set a color, I can set a color here. GL color 3F, right? Let's have some color like 0.5, comma 0.0, comma 0.8, right? Yeah, so that is something that I can set there, and it will give you some colors to your particles, right? And what else I had to do? I want to make it move along. You can see now the teapot also having a change the color of it, right? Yeah, I like to have this. So it's too big now because I'm moving it. Now it's anyway. It's going to be front of your triangle, but not on the teapot. So it's a little bit big. So I will push it back anyway, and then to make it look good. And also I want to follow the mouse in this case, right? So if I want to do that, it's pretty cool. So let's do a mouse function. So before that, let me fix that destination here to -1, or well, it was in -1, so that's fine. So let's have that, and then the color is now set, and it's die and come back, so it's fine. And yeah, so this is pretty much the basic structure. And how do you actually do the mouse move? So let's have a function called mouse move, right? And so let's have it somewhere here. Void mouse move. Right. So if you want to create a mouse move function, obviously I had to call that in my main. But what you going to do here? So let's talk about that for a minute. Mouse move means I need the previous and previous value to new value, so that's the difference between the movement. So let's have a static value, static float, right? I would say previous x, previous x, right? Set that to 0 at the beginning, and I will have static. So what is the purpose of static? Well, it is not going to change for some values, right? So that's what it will be update, but so there's no other influences coming to change it, right? So this is what the static means, right? Okay, and then 0 here, right? Here I had my mouse. I think this is 54 is much more closer. Right now it's going crazy. So let's have this one actually for my mouse move as well. So it will generate and map it right. So that's that there. And yes, I have to have so the scalar, the same thing that I do here, which is this guy right here. So this will be my scalar on mouse move. But the thing is, in the mouse move, you have to calculate the difference, right? Where you are right now, and then where you're going to move. So that is something that we have to consider. How are you going to take care of that part? How are you really going to move things, right? So that means it has to be difference between the previous and the new value, right? So anyway, mouse move going to get two variables here. One is your x value into x, and the other is into y. Why is it integer? Well, it is giving you the pixel value, so that's why it is, right? So okay, so the difference between those two that you move are usually called previous, right? X, and then that will be equal to the float. Actually, you have to convert your integers to float, so let's convert like that, and the x value minus the previous x, right? Okay, so that is the difference between the movement. So the mouse will move accordingly for that distance, right? And then I have the other one for my y, right? So this is here, and this will be your y value, and this will be your y value, like that, right? And then yes, so how much movement I'm going to take care of here? So I will get the absolute value, and if it is greater than 15 on x or the 15 on y, I will set up my previous to that value. So that will be some movement. So that means I need a little bit substantial movement on this one to move the mouse. If it is really small, you should not consider. If it is a little bit big, then you consider it as a movement, right? So in that case, let's have the previous values that you subtracting here, right? Change the previous values if it is a little bit big movement. So in this case, I will have absolute value of course you have to convert this to integers before I do this. So let's have another bracket and set int value of previous x, right? Previous int value of previous x, right? Previous x, so it has to be absolute of that. So if that is greater than 15, right? Or right, so this is your x movement, right? And or check the y moment, right? Or x or y moment. So that's also absolute value because there is a center is 0, so it can be 0 negative value as well as positive value. So in that case, I'm taking just the abs and convert this to integer value and consider the range of the previous y. So the prev y, right? Previous y is greater than 15, so this has to be greater than 15. So that is the range of your mouse movement, right? If this is the case, what I'm saying is then let's set my previous values, prev x, right, and set to the float of x, and the prev y equal float y value, right? So that is handling, and then yes, so if it is that the case, you just return right. So it's all good. So when you're setting up like that, you will update your x and y on your previous values. Only it is go beyond 15 points for the 15 pixels. So it's pos x here, right? So when you do that, I have to calculate when you do that, I want to update my mouse. Update my all the points. I want to follow the mouse when it's generating those particles, right? So in that case, let's update that here as well. So where you doing this is in the emitter. So whenever you have something like this, the emitter will take care of it and then generate the new locations, right? So let me call this emitter, and then I have a mouse x, right, dot x, comma mouse y, right? Okay, so now I have the mouse position and updating this emitter, and also yeah, of course I had to use the glut repos, right? The post display glut post redisplay. So now I'm going to post that or the print that. So let's see now what I do here. I have the previous and the current, so if the difference is more than 15, then I'm going to update that and move. Otherwise, well, you don't do anything. So in this case, I want to call this function in the callback. So this is only for the mouse move. So let's call back it somewhere here. How do you do that is you say glut mouse motion mouse. Let me recall what you're using. I think the mouse motion. So the motion function is the one which is going to use. And what you call this is mouse, right? Mouse move, right? Mouse move function, yeah. So that's what I'm going to call here. So let's see what happens. So now I will update everything accordingly. If my mouse moves, I'm going to update that, and this is where I'm going to update that, right? Okay, so let's see what happens. Oops, I have 0 here. I don't need the 0. And then let's do it again. Right, so now my mouse, when I move my mouse, my particles also moving accordingly, right? You see that? That's pretty cool, right? So this is something that you can do with the particles. So that's what we call particle engine, and right now I'm just generating some points and then just move it like that. So you can set some effects if you want. You can convert these to polygons and then wrap some texture and then do some cool stuff. Maybe you can generate fire or things like that as well. So you can do so many things using this particle engine, right? So it's a very simple basic particle engine. So this is how I'll just show you how we generate it. But you can do so many things using that, right? Okay, so yeah, so I'll call this is the particle lab, and then the next one is I will post the async setup, and then doing a very basic one. So in that case, you don't have to worry about all the things that you're doing right now in this current project that you're going through. Only the buffer part, yeah, maybe you can handle it separately. But most of the things that you do in the current project, that you can do it using async, so that is the advantage, right? Okay, so we'll talk about that in the next lab section, and then we have to do a few lectures. We'll cover that as soon as possible.